Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases.
Welcome to episode 13. We'll cover questions 61 to 65 in this episode. For questions 1 to 60, please refer to previous episodes of this series. Let's get started. Question number 61. A business is using AWS to host an election reporting website for consumers worldwide. The website makes use of Amazon EC2 instance in an auto-scaling group with application load balancers for the web and application layers. The database layer is powered by Amazon RDS for MySQL. The website is updated once an hour with election results and has previously seen hundreds of individuals check the data. The firm anticipates a big boost in demand in the coming months as a result of impending elections in many nations. A solution architect's objective is to increase websites' capacity to manage increased demand while limiting the requirement for more EC2 instances. Which solution will satisfy these criteria? So let's understand problem description here. In terms of problem, we have a election reporting website. It could be CNN Politics, it could be USSGov. This is just for example. So a website which is reporting important elections. Let's assume this is for United States of America. In terms of tech stack for this particular website, we have EC2 in load balancing situation, and they're talking to Amazon RDS for queries. And this application and website is being accessed worldwide because all the nations in the world are interested in what's happening in the United States of America and upcoming election. And that's the overall problem here. And in terms of what we want solution architect to do is, we want solution architect to increase the website capacity to manage increased demand and obviously have better latency when users are logging into the website and trying to receive the results. The biggest clue here is the website is updated once an hour, and the second one, it's a worldwide. Now, when we say website is updated once an hour, that means effectively it becomes a static website, at least for that duration. As it stands, if a lot of users across the globe log onto this website for accessing the election results, we're going to have issues with the performance, and the latency is not going to be great. If we want to solve the problem of low latency or capacity of this website, what solution we have? And now, if you look at the keywords here, it's effectively static content because the site is getting updated every hour. It's global customers. I think this is a classic case for CloudFront usage, and that's how I would solve this problem. This will be a minimal change, and the right change will put CloudFront, and through CloudFront's numerous edge locations across the world, the website will serve the election results to the customers efficiently, effectively, with lowest latency, and it will have a much better capacity to serve the customers. And the problem of that we have on the current tech stack about latency or the capacity or the bandwidth, that will disappear. So that will be my solution. Let's see if we have this solution in the given options. So we have 4 options here, and as you can see, option B is the one which is available, which we just discussed. But let's go over all the options and figure out why they are not the correct options. So first one I will rule out is option C. This option says let's enable disk-based caching on EC2 instances to cache commonly requested website content. That means every EC2 that is available in the auto-scaling group, we are going to enable disk-based caching. Now this might help with, from a scaling perspective, on these individual EC2 instances, but the overall solution is not scalable. You are, trying your luck that every time a particular result that has been cached from EC2, that would be available much more easily next time. But this is not the proper solution. Overall, the solution is not great. It will not handle the anticipated surge effectively. So I'll rule this out. That's option C, gone. The next one that appears wrong to me is the last one. It says deploy a reverse proxy into the design using EC2 instance with caching enabled for commonly requested website content. So this solution is suggesting that we have a dedicated EC2 just for caching, and this is going to add unnecessary complexity. And this option will introduce single point of failure. So if you're saying that to the load balancers that we have, we create a dedicated EC2, and if that EC2 fails, then the overall solution is not going to work. So you are back to the square one again, that there's no more caching happening, and individual EC2 are dealing with the request as they are currently. So this is a wrong option. It's not going to work. not a stable option from an architectural perspective. The next one from A and B is wrong to me. The first one, it says, let's use Amazon Elastic Cache Cluster to cache common database queries. Now, you can use cache where you have reads happening. This is not that particular situation. What you have here, you have some sort of static report of election results, and that report, overall election result will not be a single query. We are talking about the overall report might be involving multiple parties, multiple candidates. There could be various dimensions to it. So it's a set of results that people are going to request. So this is not for a specific read request which is coming out repeatedly. So option 2 is wrong. Caching database queries can improve performance to some degrees, but it doesn't address need for caching the static content, and it definitely doesn't deal with the problem that you are going to get when people from all over the world are going to access the election results. So option A is wrong. And that leaves us with the option that we have already discussed in the solution overview, to use Amazon CloudFront Web Distribution to cache commonly requested website content. So that's the correct answer for this question. Option B, CloudFront. That's it on this question. Let's move on to the next question. Question number 62. A solution architect is responsible for designing a solution for migrating persistent database from on-premises to AWS. According to the database administrator, the database needs 64,000 IOPS. If feasible, the database administrator wishes to host the database instance on a single Amazon Elastic Block Store volume. Which option satisfies the administrator's requirement? So I have highlighted keywords here, and the biggest keyword here is we need 64,000 IOPS, and we need an instance which can support this IOPS requirement. This is an article for EBS volume types. This matrix tells you different types of EBS volume types and what different characteristics they have, like durability, use cases, API name, volume size, and the IOPS volume. And that's what we want to focus on. So IOPS volume across all of these instances is on this particular row. And as per the problem description, we are looking for 64,000 IOPS, and that will be provided by EBS provisioned IOPS SSD IO1 instance. And that's the answer for this question. You need to know it. There is no other logical way of getting this answer. Let's go back to the options. And you can see the option B, create an ITRO-based Amazon EC2 instance with Amazon Elastic Block Store provisioned IOPS SSD. That is IO1, volume attached. That's what you need it, and you will configure this to 64,000 IOPS. So that's the correct answer. It's based on the knowledge area that you need to be aware for EBS instances. Let's see what's wrong with other options. This is academic exercise, but we'll go and do it anyway. So option A says, let's use an instance from i3 IO1 optimized family and leverage local ephemeral storage to achieve the IOPS. So ephemeral storage is temporary. So whatever local storage you have temporary. And when do you stop the instance, what will happen is, or the if instance is terminated for some unforeseen reasons, then it will make it suitable because that you will lose the data. So you cannot use this option. The next one wrong. Option C says, let's create a map of Amazon EFS volume to the database instance and use the volume to achieve the required IOPS for the database. Now, EFS does offer high throughput, but it's not designed for high IOPS. And it's introduced significant latency, not meeting the database's performance requirement. So it's not correct solution for the given problem. So C is ruled out. So C is ruled out for that purpose. And option D, that's the next wrong one. It says, let's have two volumes, assign 32,000 IOPS, 32K IOPS to each of them, and create a logical volume at the operating system level that will aggregate both volumes to achieve the IOPS requirement. Now, this is basically a makeshift solution. When you have a solution that is purpose-built for this particular use case, which can go up to 64K IOPS, which is the IO1 instance, then why you want to go for something that is a makeshift arrangement and going to add much more complexity to your overall solution, and you will need some sort of manual management of this application as well. So this approach is basically not a good one. This adds complexity, potential performance overhead due to additional layer of volume management and potential bottlenecks. So not a correct option. Whenever you see any problem in an AWS exam where the use case looks like a purpose-built one and the service does exist for it, you will always see an option where the same requirement is being met, where by putting multiple blocks of AWS services together, and that's always a wrong option. So you need to remember that. Always go for a service that is purpose built. Always go for minimum number of services. Always go for an option which is going to have uh, less overhead or almost zero overhead from management perspective, operational perspective. So option D we rule out on that argument, and the option that is correct for this particular question is option B that we have seen based on the documentation we have seen earlier, which is from here we'll go for EBS provision IOPS SSD I1 instance type. Let's dive into the characteristics and benefits of this particular solution. This is more like a revision. So first one is meeting IOPS requirement. We have seen this SSD type I1 volume offers guaranteed IOPS, and it goes up to 64K IOPS, and that's what the database requirement is. Single volume, we are not fiddling with multiple volumes here. One of the option D suggested that. So obviously we are not, it's a simple solution. We are not creating any more complexity by trying to put multiple instances to satisfy the IOPS requirement. And the final one is the Nitro-based instance. The Nitro-based instance offers superior performance and lower latency as compared to traditional instances. To be honest, even if this was not a Nitro-based instance, this one has already ticked and is a better option than everything else that was there from a 64K IOPS perspective. So that's it on this question. Let's move on to the next question. Question number 63, a solution architect is tasked with responsibility of creating architecture for a new application that will be deployed to the AWS cloud. Amazon EC2 on-demand instances will be used to execute the application, which will automatically scale across different availability zones. Throughout the day, EC2 instance will scale up and down periodically. The load distribution will be handled by an application load balancer. The architecture must be capable of managing dispersed session data. The firm is ready to make necessary adjustment to the code. What is the solution? Architect's responsibility in ensuring that the design enables the distributed session management. So the keyword here for this question is distributed session management. And I would like to refer to AWS documentation and article about distributed session management. And this particular article clearly says that you need to use caching, Elastic Cache for Redis, Memcache for distributed session management. If you want distributed session management, this is the solution you go for. And here is a diagram which explains you how you would be able to go to distributed session management. You can go through this article and the diagram and the related documentation for at your own time. I will provide you a link to this article in video description of this video. But the main point I wanted to make is if we want to achieve distributed session management, the solution that you have is this. You need to use Amazon Elastic Cache to manage and store session data. And this will be our possible answer. Let's see what we have in the question in terms of options. I have highlighted our keyword again here. Managing dispersed session data is the important keyword here. And what we need is we need a solution for distributed session management. And as you can see, option A does cover what we have seen in that article from AWS documentation. Let's go and evaluate other options as well and see if and figure out why those are incorrect. So the first one wrong for me is option B. So sticky sessions is not going to be the answer for it. Sticky sessions of the LB routes all requests from a user to the same instance, but this doesn't address the issue of session data being lost if the instance scales down. If the instance is gone, your session data is not going to be maintained. So this is not the answer. We'll rule option B out based on that argument. Option C that says let's use session manager from the AWS system manager to manage the sessions. Now, the word session has been used here to mislead us. The session manager in this particular case doesn't do anything to do with distributed session management. It basically manages the remote access to EC2 instances. So the word session is the remote session, not the distributed session management in the context of this particular problem. So it's incorrect. And in fact, the next one is also incorrect, option D, where the word session is used in a wrong context. Get session token API operates in AWS SDS is used for get session API is used for temporary security credentials. So it's basically your temporary way of logging on, and it's not used for managing the session from an EC2 ALB session perspective. So this is an incorrect option as well. And the correct answer for this question is option A, which is Amazon Elastic Cache. That is what you use to manage the distributed session data. So this is a fairly simple question from an elimination perspective. because option B, C, D, each of them use word session in a different context, and that has nothing to do with managing the session data for a distributed session scenario. So correct answer for this question is option A, use Amazon Elastic Cache to manage and store session data. That's it on this question. Let's move on to the next question. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 64, a business want to move a workload to AWS. The Chief Information Security Officer demands that any data stored in the cloud be encrypted at rest. The cloud organization desires total control over the encryption key lifecycle management process. Independent of AWS CrowdTrail, the organization must be able to promptly delete key material and audit key use. The selected services should interface with other AWS storage services, which services adhere to these security standards. This is a security question. Let's jump in and understand what do we have in terms of keywords here. So this is on-prem move scenario, migration scenario. Before moving the data, we want to make sure that encryption is done on the data. And another keyword here is important keyword is organization wants complete control over the encryption key and the lifecycle management process of the key. They should be able to delete the key material and audit key, which is again extension of read control. Should be able to interface with other AWS storage services so that you can then actually make use of the encryption mechanism that we have put in place to encrypt the data in those storage services. Let's go over all options and see which are the correct options here. So first one, it says let's use cloud hardware security module with the cloud hardware security module client. Now, cloud SSM will provide you hardware-based key storage. That's fine, but it will not integrate with other AWS storage services. So this is a limited use. So just on that requirement, this particular option is not correct. So integration with other AWS storage services is also important. Unless you are able to integrate with storage services, there's no use of security and encryption mechanism that you have. If you cannot encrypt anything, then it's useless. So option A is ruled out for that reason. The next one incorrect to me is option B, AWS key management service with AWS Cloud HSM. So I think there are two parts to this, what you will use for key management. And the second part is what are you going to do with for the control of the key. So the first one is, so in this particular option, this option combines KMS with Cloud HSM, fine, but it does not allow organization to import their own key material, limiting the control over the key lifecycle. The second part is not correct. Organization doesn't have the control over key lifecycle management, so this option is wrong for that reason. And option D, that one is an extension of option B. Over here, this option uses KMS, but then it uses AWS managed keys. Now, if you have AWS managed keys, that means customer doesn't have the control. So this cannot be used as the solution because it doesn't conform to the requirement that we want the organization or the customer to have full control of lifecycle management process for the keys. So this is gone. And that leaves us with the option C, which has AWS KMS, which is the correct solution. And it uses external key material origin, which allows customers to have the full control over the lifecycle policy of the key management process. So this is the correct answer. We will dive into the details of various aspect of this particular selected option in the next slide, which is here. So first one, I think we'll go match every requirement and see how does the option cover. So first requirement was encryption at rest. And I think this is a simple one. AWS KMS provides this encryption at rest, and it integrates with services like EBS, S3, and other storage services. Control over lifecycle management. I think this is the key requirement where option D was ruled out, and in fact, option B was ruled out. So this option where we have external key material origin option, the organization can import their own encryption keys into AWS KMS. Then this gives them full control over the key lifecycle management process, including the ability to delete the key material and audit key usage, which was also an explicit requirement in the problem. And that's again highlighted here. So we've already covered it. AWS KMS will allow the organization to promptly delete the imported key material, effectively rendering the encrypted data unreadable. And additionally, KMS provides detailed logging and auditing capability as well. So that's another plus point why this option is the correct one. The last one, I think integration with AWS storage services, which is a very important one. KMS integrates seamlessly with various services like S3, EBS, RDS, and allowing organization to encrypt data stored in these services using their imported keys. So overall, this is the perfect solution. other options we saw, why they were incorrect. And that's all on this particular question. Let's move on to the next question. 65, a business hosts an application on Amazon Web Services and utilizes Amazon DynamoDB as a database. To handle data from the database, the organization adds EC2 instance to a private network. The organization connects to DynamoDB using two NAT instances. The corporation wants to decommission its NAT instances. A solution architect must develop a solution that connects DynamoDB and is self-managing. Which approach is the most cost-effective in terms of meeting these requirements? So before jumping into various options, I have an article from AWS here. This is a scenario that we have an EC2 instance, which is in a virtual private cloud. And obviously it cannot then talk to the rest of the world directly. And we have Amazon DB as well over there. And in order for access to Amazon DB, you should be using VPC endpoint. Why? Because right now you cannot have EC2 instance directly communicate with your Amazon DB. We also want to make sure that all of this is away from internet so that it is secure. So VPC endpoint is your answer. I will provide a link to this particular article in video description. Let's jump into now the analysis of the problem and see why other options were not correct and if the answer we have just referred is available in the options that are presented to us. So I can see that option A is the answer for this question that we have selected. So we are okay on this, but let's eliminate others and figure out why they were incorrect options. And first of all, you should know if you have anything in VPC, you cannot communicate it to directly. So you need some sort of mechanism. And the mechanism that are available to you are you have NAT gateway, you have NAT instance, you can have direct connection as you have here or other various options. Because if you have something in VPC, it is your virtual private network. In order for any communication between a VPC to other VPC or VPC and the outer world, you will need some sort of mechanism to interface for translating and at the same time protecting what is in the VPC. So hence you need all these kind of equipments. Communicate if you have some services in VPC. Anyways, let's move on with the option evaluation. So first option says, let's have a managed NAT gateway to provide connectivity to DynamoDB. I think we should refer back that we already have two NAT instances and organization wants to get rid of the NAT instances and replace it with something that is effective, fit the requirement, and obviously is a managed service so that you don't have any overhead of managing this solution. Now, let's see option B. What do we see? Yeah, we were talking about NAT gateway. It does eliminate managing NAT instances, so that's okay. But your NAT gateway is going to be an additional cost compared to VPC gateway endpoint because that solution is, I think, effectively free. We will look at some documentation around that as well. But I believe VPC endpoint is a free solution and it is a secure one as well. It doesn't bring in any internet traffic in the solution. So as compared to VPC endpoint, this is not a better solution. So option B is ruled out. This is why I have discussed solution with you, because to approach this problem, you have to compare it with VPC endpoint, which is you already know that now it's a correct answer. You cannot eliminate these options without a reference to the correct answer. The next one is direct connect. It says let's use direct connect between the private networks and DynamoDB. Now this will work. Technically, theoretically, it will work, but this is an overkill. Direct connect is not used for connecting services within an AWS zone or a region. It's used for connecting your on-premise services with AWS. That's where its utility is, and that's where you can have a solution like direct connect, which is very expensive, but it's needed for on-prem to AWS connection because it's a secure solution and it is worth the price for that scenario. Here you are talking about it's a single region situation, everything is in AWS, and for communication between them, you don't need direct connect. So it's a overkill and expensive option. This fails on the cost aspect of the requirement mentioned in the question. So option C is gone. We rule that out. And the last one is option D. I think this one is also incorrect. This is making use of private link endpoint services between private network and DynamoDB. Will this work? This is designed for services you host within your VPC and want to share privately with other accounts. So this is inter-account conversation. If you want to do, then it is used. It is very unnecessary solution, again, like option C, for connecting native AWS services like DynamoDB. So it's not the right purpose of this solution. As mentioned earlier, this is used for when you host different services within your VPC and want to share privately with other accounts. So most likely you can bring this solution when you have maybe multiple accounts sharing the resources. So it's wrong option for this scenario. And what is left is our option A, VPC endpoint. That's what you will use in this situation to replace the two NAT instances that we talked about in the problem. So that's our correct answer, option A. Let's go over various characteristics of how this option is better than others. The first is it's cost effective, and VPC endpoint is actually a free service if you're accessing AWS services within the same region. Now, if you have something free purpose built for it, you'll go for that instead of going for other options. And that's the reason why we've gone for this option. One of the main reason, cost effectiveness. It does the job that it needs to do. It's self-managing. Once configured, the gateway VPC endpoint, it automatically manages the connection to DynamoDB. So you don't have any operational overhead. It's self-managing solution. Security, it keeps the traffic within AWS network. You do not interfere with any public internet access. That means your data is safe within AWS. And this mechanism for connecting your DynamoDB to your VPC resources keeps it secure within AWS, and perfect solution. There is an article from AWS about VPC endpoints. It doesn't directly address the key problem that we have here, but you could refer to it to understand how does the VPC endpoints work and how can you save cost and security using VPC endpoints. It also talks about other mechanisms and compares them when you are trying to access resources which are in a VPC. So please go over it at your own time. And that's it on this question. And I believe that was the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you.
This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.